Hello, welcome to this lesson. Here we are going to consider integral of trigonometric functions of sine and cosine with odd powers. Let's take an example. Here we use different approach because the power of sine is odd as compared to the previous lesson where the power is even. Instead of half angle identity as used in the previous lesson, the standard strategy for integrating odd powers of sine or cosine is to split off one of the sine factor and use the Pythagorean identity. We rewrite the integral of sine cube x dx as integral of sine x dot sine squared x dx. And after that, we replace the sine squared x from the Pythagorean identity of sine squared x plus cosine squared x equals 1. So we are going to make sine squared x the subject, then we use that to replace what we have here. So note, for even powers of sine and cosine, use half angle identity, whilst for odd powers of sine and cosine, use Pythagorean identity, that is sine squared x plus cosine squared x equals 1. Take note of that. So making sine squared x the subject, we are going to get 1 minus cosine squared x. So we are going to substitute this in place of sine squared x. So now we have integral of sine x by 1 minus cosine squared x dx. So we can multiply through by sine x, and that gives us integral of sine x minus sine x cosine squared x dx. Applying the integral symbol and then variable of integration, we get integral of sine x dx minus integral of sine x cosine squared x dx. And obviously we can easily integrate sine x. But here we can integrate this using the substitution method. So taking integral of sine x cosine squared x dx and considering this, you can see that substitution method will work. That is, when we let the u to be cosine and we differentiate it, that will give us sine. That will come to cancel the sign over here for us to get everything in terms of cosine. So let's do it. Let u equals cosine x. The u equals negative sine x dx. So making the x the subject, the x becomes negative du on sine x. Substituting everything back into this produces integral of sine x, and now cosine squared x now becomes u power 2, then the x is now negative du on sine x. Whilst sine cancels sine, and we have integral of negative u squared du. This produces negative u power 3 on 3 plus c, but u is cosine x, so let's substitute that, of which this implies that we're going to get negative cosine cube x on 3 plus c as a result for just this alone. So bringing everything together from here, our final answer becomes negative cosine x, that's the integral of sine x dx. We have minus, and this also produce minus, so that will give us plus 1/3 cosine cube x plus c, and that becomes the result for the integral of sine cube x dx. Note, from the integral of sine x cosine squared x dx, you realize that we had negative 1/3 cosine cube x plus c, and from this there can be a generalization. So let's look at it. Anytime you have integral of sine x by cosine power n x dx, that gives us negative 1/n plus 1 cosine n plus 1 x plus c. Comparing what we have here with this, you can see that everything is the same except that the n now becomes 2. And over here, you can see the 2, which is the n, increased to 3. That simply means that this particular power for the cosine increased by 1. So we had n plus 1. Then we divide the results, that is the cosine power n plus 1 x, by the negative reciprocal of the power n plus 1, and that will give us negative 1/n plus 1. So again, this simply means if you have integral of sine x cosine power 3x dx, that will produce negative 1/4 cosine power 4x plus c. What of integral of sine x cosine power 4x dx? The same way, we are going to get increase this one by 1, so that will give us cosine power 5x. Then we multiply by negative reciprocal, that's negative 1/5, then plus c. So this is how we generalize this, and not this alone. Also, situation where we have integral of cosine x sine power n x dx. This also gives us the same thing, sine to the power n plus 1 x multiplied by 1/n plus 1 plus c. So the difference between the two is that for situation whereby the sine carries the power, it is positive, and situation where the cosine carries the power, it is negative. That's the only difference. So in that case, situation where we have integral of cosine x sine power 2x dx, that will produce 1/3. We increase the power by 1, sine cube x plus c. Again, cosine x sine cube x dx will also be 1/4 sine power 4x plus c. So take note of this generalization so that you can avoid the process of solving it all over again. Let's take our second example. Integral of cosine cube x dx. Solution. We can write the integral of cosine cube x dx as integral of cosine x cosine squared x dx. Cosine squared x is equal to 1 minus sine squared x. So substituting, we are going to get integral of cosine x bracket, then this replaces what we have here, 1 minus sine squared x bracket close dx, then multiply through by the cosine x, and that will give us integral of cosine x minus cosine x sine squared x dx. So integrating, we are going to have integral of cosine x gives us sine x, then integral of cosine x sine x. From here, we learned that we need to increase the power. It's still going to be minus. Then we have sine cube x multiplied by the reciprocal of this 1/3 plus c, and that is our answer. Thank you very much for watching. This is the end of this lesson. Bye bye.